Hello everyone, welcome back to ITWinners Academy. Here we have one-sided limit. If I have f of x function defined on open interval c to a, the expression of limit f of x equal to q1, and here x approach a negative. This means f of x approach q1 only if x approach a, but here x approach a through value less than a. Okay, so here x less than a, and this called here left hand limit. Okay, again with right hand limit. So as f of x function defined on open interval here a c, then the expression of limit f of x equal to q2, and x here approach a positive. Here I can say that f of x approach q2 only if x approach a, but through value greater than a. Okay, and here x is greater than a. Okay, so from left hand limit and right hand limit, I can say that if so, from left hand limit and right hand limit, I can say that a function f of x defined on any open interval, even if f of x not defined on value of x equal to a, f of x here will approach q only if here x approach a from left and right. Okay, so here the limit of f of x equal to q, and here x approach a will be exist only if limit f of x approach a negative equal to limit f of x, and here x approach to a positive. Okay, example 1, given here f of x equal to divided into intervals. So here f of x equal to 2x plus 1, and here x from 1 to 3, and here x squared minus 2 on the interval 5, here 5x here on the interval. Okay, and ask here to find limit f of x when x approach to 1 positive, limit f of x approach to 3, limit f of x approach to 5, limit f of x, and here x approach to 7 negative. Okay, so solution of first one, let's find limit f of x, and here x approach to 1 positive. As you see here at this interval, so this limit will be equal to 2x plus 1, and here x equal to 1, so this will be equal to 3. Okay, second one, limit f of x approach 3, this will be divided into two direction of solution. So here let's find limit f of x when x approach 3 from negative side, and here limit f of x when x approach 3 from positive side. Okay, so from negative side we will find this defined on this interval, so this will be equal to 2x plus 1, here x equal to 3, this will be equal to 7. Okay, again x here approach 3 positive, and this defined on this interval, so this will be equal to x squared minus 2, and here x equal to 3, this will be equal to 9 minus 2 equal to 7. So the limit on left hand equal to limit on right hand. So limit here is exists. Again with 5, limit f of x when x approach to 5. Again, this also well divided into two directions. So we will find limit f of x approach to 5 negative, and here limit f of x when x approach to 5 positive. This divide on this interval, so this will be equal to x squared minus 2, and here x to 5, so this will be equal to 23. Okay, here this depends on this interval, so equal to 5x, and x here equal to 5, this will be equal to 25. As you see here, the left hand limit doesn't equal to right hand limit, so limit f of x when x approach to 5, so limit here doesn't exist. Okay, again with last one, limit f of x when x approaches to 7, and just find the last one here, so this will be equal to 5x, and x here equal to 7, so this will be equal to 35. Okay, another example for the draw function, ask to find here limit f of x when x approaches to 0 positive, and here limit f of x when x approaches to 1, limit f of x when x approaches to 2. Okay, so let's define this function as interval 4. So f of x here will be equal to, here f of x equal to 1 when x equal to 0. So here we have 1, and here x equal to 0. Here f of x equal to 2 minus x, and here x from 0 to 1. Okay, again f of x equal to 1 when x between 1 and 2, and here x equal to 4 minus x when x between 2 and 4. Again f of x will be equal to 0 when x equal to 4. So just we can define this here. Okay, so let's start to find our limits here. From the first one, limit f of x when x approaches to 0 positive will be equal to this defined on this here interval, so 2 minus x, and here x equal to 0, this will be equal to 2. Okay, limit f of x when x approaches to 1, this defined on two intervals, so here I will find limit f of x when x approaches to 1 negative, and here limit f of x when x approaches to 1 positive. Okay, so that's defined on this interval, so here 2 minus x, and here x equal to 1, so we have here 1. That's defined on this interval, that's equal to 1. So the limit on left hand equal to limit on right hand, so this limit is exists. Okay, again with last one, here limit f of x approach to 2, well divided into two limits, so we have here limit f of x when x approach 2 from negative side, and here limit f of x when x approach 2 from positive side. Okay, that's defined on this interval, so this will be equal to 1. That's defined on this interval, so this will be equal to 4 minus x, and here x equal to 2. So we have here 2. Okay, the limit on left hand doesn't equal limit on right hand, so this limit doesn't exist. Okay, another example here, asked to find limit f of x when x approaches to 1, limit f of x when x approaches to 2, and here limit f of x when x approaches to 3. Last one, limit f of x when x approaches to 4 negative. Okay, so again, let's redefine this function on intervals 4. So f of x here will be equal to here the first part here of this row represents x plus 1 when x from 0 to 1. Okay, and here f of x equal to 1 when x equal to 1. Here f of x equal to 2 when x between here 1 and 2, x equal to 1 when x equal to 2. Here in this part here f of x equal to 4 minus x when x between here 2 and 3, and here at this part f of x equal to x minus 2 here from 3 to 4, and here equal to 1 when x equal to 4. Okay, so let's start with this one. Limit f of x when x approaches to 1 will be divided into limit f of x when x approaches 1 negative, limit f of x when x approaches to 1 positive. This equal to here x plus 1, and here x equal to 1. This will be equal to 2, and here defined on this interval equal to 2. Okay, so this limit exists. Okay, again with next one, limit f of x when x approaches to 2 divided into 2. Limit, we have here limit f of x when x approaches to 2 negative, limit f of x when x approaches to 2 positive. This is defined on this interval, so this will be equal to 2, and this defined on this interval, so this will be equal to 4 minus x. Here x equal to 2, so this equal to 2. Okay, so this limit also exists. Limit f of x when x approaches to 3, limit f of x approaches to 3 negative, limit f of x when x approaches to 3 positive. This this defined on this interval, so this will be equal to 4 minus x, and here x equal to 3, so this equal to 1. Again, this defined on this interval, so this equal to x minus 2, and here x equal to 3, so this also equal to 1. Again, this exists. Okay, last one here, limit f of x approach to 4 negative, is defined on this interval, so this will be equal to x minus 2, and here x equal to 4, so this will be equal to 2. Okay, Thank you for watching.